It's my 3710 class. Anyway, okay, so I'm looking at this crowd, and maybe I'm going to spend more time then on the easier problems in this set. I will say a few words about the harder problems, I guess, in the set too, so people that watch the recording can see what I have to say about those harder problems. So let me share my screen. And this is the practice contest. I know some people at least looked at it. I think, Rob, you try some of the problems, at least one problem. Is this you?
Yeah, I tried. Oh, yeah, I was Roy Donk. Yeah.
I could not figure out who D2.js is. I'm guessing it's Dustin and whoever is,
yeah.
but I'm not absolutely sure.
Was that? I know Rocky was here. So I'm not sure if he got any on. So maybe,
yeah,
maybe
well, I only see two that claim to be University of Lethbridge. I don't know if anybody else tried. Anyway, okay, so looking at this crowd, I think most of you are more beginner type that have not a lot of experience. So I'm going to stick to the easy problem, and I'm actually going to be a little bit slower and go through more details. The one thing is I brought my writing tablet home, but somehow my pen, I forgot to take my pen. So that means I can't write on my tablet. I'll just type and hope for the best. Okay. And maybe I'll even code in front of you and see what happens. See if I can actually put this in play and make sure that I can actually do it in front of you. Okay, so baby bites. I think this is the supposedly the easiest problem in the set, and that's the one that Rob tried. But anyway, let's read the problem. So Arild, I don't know, this is some sort of Nordic name, I guess, just turned 1 year old, and it's currently learning how to count. His favorite thing to count is how many mouthfuls he has in a meal. Every time he gets a bite, he will count it by saying the number out loud. Whoever wrote this is probably not a parent. I don't think kids count at 1 when they just turned 1. Anyway, unfortunately, talking while having a mouthful sometimes causes Arild to mumble incomprehensibly, making it hard to know how far he has counted. Sometimes you even suspect he loses his count. You decide to write a program to determine whether Arild counting makes sense or not. Okay, so what is it that you're supposed to do? First line of input contains an integer n, which is between 1 and 1,000, the number of bytes that he receives. The second line contains n separated words spoken by Arild, the ith of which it's either a non-negative integer ai or the string mumbo. And then output, either you say makes sense or something is fishy. So if his counting makes sense, print the string makes sense, otherwise print something is fishy. Okay, so here's some example. 5 of them, 1, 2, 3, mumbo 5. So the mumbo could have been 4, so that makes sense. 8, 1, 2, 3, mumbo 7. Well, that 7 should have been a 6. So that doesn't make sense. And then 3, mumbo, it says it makes sense. So basically when you hear mumbo, you don't know anything, right? But if you see an actual number, then you have to make sure it matches what it's supposed to be. That's basically it. Does that make sense? Okay, so if it makes sense, then I want to maybe just code it and in front of you, and then see how far sort of what I would do. Let me just make it a little bit bigger. Is it big enough for people to see?
Yeah, it looks good.
Okay, so I generally do this, include bits, standard C++.h. You don't have to like this. You can include individual things like IOStream or whatever you need. In this problem, I guess you really only need IOStream, but bits/std C++ is just basically include the kitchen sink. Every single possible thing you can include, it includes it. It's definitely not recommended in real life. In your big software project, you do not want to include things that you don't need, but this is for programming contests. If I want to do things as quickly as possible, this is what I do. Okay, so here we are. This is a standard program. I haven't done anything yet. First line of input contains an. Oops. So I read in an. And then they tell you that they're n space separated words. Now, when they say that, you don't have to worry about whether they trick you by giving you fewer words, more words, not separated by space or whatever. It's automatically guaranteed. So immediately I can just start saying for I equal to 0, I less than n, I plus plus. And then I have to read something. Now, the question is, what do I read into, right? They could be a number, could be a string. So I cannot read it into an integer variable because if it's a string, then I would fail. So what do? I'm just going to read into a string. Okay. And then if s is equal to mumbo, then I actually just ignore it. So I guess one way to ignore it is just continue. Or if you don't like that, you can say if s not equals to mumbo, then do something. Okay. So you can do it either way. And now if I'm down here, that means I'm not mumbo, so it has to be a number. So what is the number, right? So I'll just say, they call it A. Now I have a string that represents a number, and I want to convert the number. One way to do it is S to I. It's a C++ function to take a string and convert it to an integer. So here we are. Now we have a number. What do we have to make sure? We have to make sure that it is the right number. What is the right number? I look at the loop. I count from 0 to n minus 1, so the right number is I plus 1. So if A is not equal to I plus 1, then I see out something is fishy. And as soon as I see out that, I can quit the whole program. That's it. I found one example, that's it. And if I don't find it, I have to keep reading. And if I manage to get all the way to the end and I haven't found something fishy, then I'm going to print makes sense. If I can type properly. Let me just make sure that this is exactly what I have to do. If something is fishy, makes sense. Okay. Does that make sense?
Yeah, it does. A lot more simple than what I did.
Is it a lot simpler than what you did, Rob?
Yeah, it is.
Okay. All right. So now we're going to try to submit it and see if it works. Notice that I didn't even bother compiling or running it because I feel confident that this is right. Okay, so it's when you compile and run it and check and see if it works, right? You're kind of, oh, I'm not a participant. Shit, I have to sign. Okay, hang on. I can do it without going into this contest. I'll just submit it from here. Okay, so I'll do it in the open. When you compile and run and whatever, I guess this is you asking your computer, please check your work, my work. I'm saying I'm not going to even check my work because I'm confident that's correct. Let's see. Who knows? Maybe I don't even get compiled. Okay, so at least it compiled. Okay, so that looks pretty good. I mean, of course, there are many ways you can do this, but this is how I would do it. Now, there are other things that maybe I would say. Some people might think that this is, counting from 0 to n minus 1 and then comparing to I plus 1 is maybe a bit confusing. Maybe if you just count it from 1 to n to begin with, then you just match it to I. It's up to you. I personally write all my loops almost always from 0 to n minus 1. Just that's my style. So then I adjust everything to match that. That's just the way I like to do things. But you might want to write from 1 to n instead. Okay, so that's that one. Are there any questions before I move on to the next one? So with a problem like this, right, it's not that it is hard. Right? Most people can eventually get it, but the question is how fast can you do it, and then how much code or how much effort and debugging and so on do you need to make it work, right? And I guess even doing these simple problems that doesn't require any hard algorithmic knowledge, as doing as many of them as you can, right, basically makes you better programmer for most things, because you'll be more careful to making sure everything is right. Okay, so what's the next problem that seems to be popular? So 21 and then 16, code cleanup. Okay, so let's look at code cleanup. Okay, so there's a bit of reading. The management of the software company Junk Code has recently found, much to their surprise and disappointment, that productivity has gone down since they implemented their enhanced set of coding guidelines. The idea was that all developers should make sure that every code change they push to the master branch of the software repository strictly follows the coding guidelines. After all, one of the developers, Perinkos, has been doing this since long before these regulations became effective, so how hard can it be? Rather than investing a lot of time figuring out why this degradation in productivity occurred, the line manager suggested they loosen the requirement. Developers can push code that weakly violates the guidelines as long as they run cleanup phases on the code from time to time to make sure the repository is dirty. Okay. She suggests a metric where the dirtiness of a developer's code is the sum of the pushes that violates the guidelines, so-called dirty pushes, made by that developer, each weighted by the number of days since it was pushed. Okay. The number of days since a dirty push is a step function that increases by 1 each midnight following the push. Hence, if a developer made 30 pushes on days 1, 2, and 5, then the dirtiness of day 6 would be 5 plus 4 plus 1. So 5 days since the first push, 4 days since the second push, and 1 day since the last push. So added together is 10. She suggests that a cleanup phase, completely fixing all violations of the coding guidelines, must be completed before the dirtiness reaches 20. One of the developers, Petra, says that this rule must be obeyed not only because it's a company policy, breaking it will also result in awkward meetings, blah, 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 blah. Okay, still, she wants to run the cleanup phase as seldomly as possible and always postpones it until it is absolutely necessary. A cleanup phase is always run at the end of the day and fixes every dirty push done up to and including that day. Since all developers are shuffled to new projects at the start of each year, no dirtiness should be left after the midnight at the end of New Year's Eve. So basically, you have to keep track of how much dirtiness you have. And if it's about to go over 20, you must clean up. And then the last sentence basically says, you must also clean up at the very end. Okay, input, you have integer n, 1 to 365, the number of dirty pushes made by Petra during a year. The second line contains n integers, d1 up to dn, each between 1 and 365. Given the days when Petra made 30 pushes, you can assume that basically this list of numbers is sorted. I'll put the total number of cleanup phases needed for Petra to keep the dirtiness strictly below 20 at all times. Okay, so you have basically 1 year, and I assume 1 year means 365 days here. They didn't explicitly say that anywhere, but it seems to be what they're assuming. And then some days you have 30 pushes, and then you want to clean up whenever you're about to go over 20. You're never allowed to go over 20. It must be completed before it reaches 20. Also, if at the end you have any dirtiness, then you must clean up as well at the very end. Okay, so what should we do? There are only 365 days. 365 is very small in the grand scheme of things. So we really just want to simulate it 1 day at a time. Every day, we're going to keep track of what is the dirtiness. And then if the next, so how do we decide whether we clean today? We clean today, right? So if the next day we go over 20, then we must clean today. So somehow to decide whether we clean today, we have to know what's going to happen tomorrow. Does that make sense? And so if that makes sense, then the question is, how do we make sure that we keep track of the dirtiness every day? Okay, so what is it called again? Code cleanups. Code cleanups. So let me change this. Code cleanups. Okay, so I'm just going to get rid of this. This is my main program again. I don't have anything yet. I have to first decide, what am I going to have to first decide? I'm going to have to first decide how to represent my data. I got a number of days that are dirty, and I got this day. So one way, I suppose, I could say, why don't I just store this in an array of n things, right? They tell me that I have a bunch of days, store them all. That most 365 days, so I can store it as an array of at most 365 things. But turns out I don't think this is the best way. I think the best way is actually have an array that remembers for each 365 days whether something is dirty or not, and I'm going to just step forward with this array. Okay, I'll kind of explain what I'm doing. So let me just do this and notice that, okay, so I'm going extremely slowly the way so going through my thought process as I write this. I have decided to use 365, and immediately, I guess what I think when I'm writing this is, should I use 365 or should I use something else? Because the numbers that I'm given is 1 to 365. So if I just use those numbers, I would have to use 366 because it starts at 1, counting at 1 all the way up to 365. Whereas here, the way I do it, I'm using 0 to 364. It doesn't actually matter, right? It doesn't matter what I do. I only have 365 things. The only thing that I have to remember is, if I do this, then I better make sure that I remember to adjust everything. So I'm just going to make this 366, so I don't have to adjust. I'm just going to use day 1 to 365. So every time you write an array bound, okay, think about whether this is the right bound. Because if you break the wrong bound, then of course bad things can happen. Okay, so that's the first part. Okay, of course I have somebody asking me for help for 3710, but I'll ignore it for now. Okay, so now I have n, read in n, and for all the numbers, I'm going to read in a day. And that reads, that sets the array. Okay, now maybe you don't know this. So you can initialize an array by listing every single entry, right? So I can type false 366 times. Okay, but of course I'm not going to do that. I'm going to lose track fairly quickly. But in C++, you can initialize just any number of entries. So in this case, I just initialize 1 entry. What about the rest? The rest, if you don't specify, the rest are automatically initialized to 0, which for Booleans, 0 is the same thing as false. So by just initializing 1 entry, this actually will initialize all of it to false. Now, the same trick cannot work if you want to initialize things to true, because when you don't specify, everything is going to be initialized to 0, so then you're not initialize everything to true. So this will work for false. If you don't like that, you can use this stl command that initialize the entire array with a certain value. Or if you don't even like that, you can use it just write your own for loop. But anyway, this is what I do. Okay, so now what am I going to do? I'm going to have a count on how many times I clean up. Okay, so I just call it answer. And then initialize is 0. Every time I have to clean up, I remember to increment this by 1. Then I'm going to step through the days. Let's call it D. And because I'm using 1 base, I'm stepping through from 1 to 365. And then somehow I have to say if dirtiness, so I have to figure out how to compute dirtiness, it's greater than or equal to 20, then do something. Now, there's a bit of an issue here. The issue is the dirtiness when. Because the dirtiness here is the dirtiness of next state. Okay, so somehow I have to know the dirtiness of the next state, not dirtiness today. Okay, so let's think about what's going on. So I have to have some way of computing dirtiness. Initially, I'm just going to pretend that there are no dirty ones. Okay, the dirtiness is 0 because at the beginning nothing happens. What else are we going to do? Okay, so now we have to think about how we keep track of this dirtiness. So and 365 here, if you don't want to be super smart, right? Maybe you don't even have to keep track of this dirtiness. You can just say, every day I'm going to go back, look backwards. Right, so int j, int dirtiness equal to 0 for every day, call it previous, which is d minus 1, as long as greater than 1 d, so I'm previous minus. So I'm looking backwards, the previous days, if 30 previous. So if that day is 30, then dirtiness, it's equals to the current day d minus previous, right? So if I'm on day 5 and d and the previous is day 3, then the dirtiness for that day is 2. So I add it all up. And now, what do I say? If the dirtiness is greater than or equal to 20, then that means I have to clean up the day before. Because I want to make sure that I don't reach 20. So if today is the day I reach 20, then I should have cleaned up the day before. So I have to say answer plus plus. But now that I've cleaned up, I also have to go backwards. I'm cleaning up the day before. And clean up it the day before means that I set all of them to be not dirty anymore. And then finally, I guess I can just say, if there's still anything dirty at the very end, then I must clean up. So, I guess I don't need this dirtiness here. Every time I clean up, I actually physically go and get rid of the dirty bits. So if I can just search, so if I can actually use this STL, 30 plus 366. If I count anything, it's still dirty. So this just look at the array and ask how many true values are there. And if it's bigger than 0, then I have to clean up one more time. And then finally, I print. Okay. Does that kind of make sense? Right. So for each day, I look backwards and find all the 30 pages, 30 lines, sorry, 30 days. For each 30 day, I sum things up. My current day minus the previous. And then if dirtiness, it's going to be 20 or more, then I'm going to clean up the day before, and I go backwards, starting from the day before, not today, starting from the day before, and clean everything up. Does that make sense?
I'm a little confused how the dirtiness accumulates. Like
okay.
Reading comprehension, I suppose.
Okay, so let's say that okay, since I don't have to write, so let's say I have a bunch, I have 10 items, and this is let's say my dirtiness array. It's true, false, false, true, false, true, false, false, true, true. Let's say like this. So on day one, I'm here. I don't have to worry about the dirtiness of something in day one because the distance is 0 anyway. And I look backwards. Well, there's nothing to look backward. So dirtiness is going to be 0. So nothing happens. Now I'm in the next part. I look backwards and I find all the dirtiness. I see this T at index 1. I'm on day 2, so I know that the dirtiness is 1. And then here, I'm at day 3. I look backwards. It's not dirty, so I don't do anything. Day 1, I'm dirty, so it's 2. And this one is 3. And then 5, I look backwards. There's a dirty one, so I add 1. Then I keep looking. There's another dirty one. So I add the 4. So altogether, the dirtiness is 5. Does that make sense?
Yeah, that makes sense.
So this loop, this inner loop, just go backward to find all the T's in the dirty array. And then if it is true, then I got to add the distance between that day and the current day. And that's where this part is. I add them all up. And then if that number is bigger than or equal to 20, then that means I have to clean up the previous day. Does that make sense?
Yeah. And when you're cleaning, are you just like bringing that accumulation back down to 0, right?
Okay. So I actually never explicitly set my variable back to 0, but then because I initialize it here at the beginning of the loop, so this dirtiness is always initialized to 0 for every time that I start on a day and look backwards. Okay.
Okay.
So here's another thing, I guess. This is something that I do and not a lot of people don't do. You notice that I declare variables, not all the things at the top, right? I declared this D inside because this D I only care about this D inside this loop. I don't care anymore outside. Here, this dirtiness is the same, but also because I'm initializing things to 0 here, every time when I come back to the next iteration of the loop, this automatically reset thing to 0.
Okay.
Right? Some people might write things like this. They put here and the outside because they have been told to declare all their variables at the beginning. And then they run it and then they say, oh no, I forgot to clear it. So after everything is done, I'm going to clear like this, right? But now you see you're writing the same code twice, right? You're writing equal to 0 here. You're writing the same code here. It's easy to forget any one of them, right? But if you just declare and initialize, right? Always declare and initialize at the same time, like here, then every time you come through the loop, it will initialize. You don't have to worry about clearing it at the end.
Oh, good to know.
Okay, so now let's see if I'm brave enough to just submit without compiling and running. I forgot. I have to get out of this contest. Contest practice. Where did I put it? Temp. Code cleanup. Submit. Okay, does it compile? It compiles. Does it run? Check marks, check marks. Okay. Solved it. Okay, so now, right? So maybe I should ask then at this point, I mean, this is Okay, for maybe not for you, but for me, it's an easy problem. Okay, by easy, I mean there's not a lot of deep algorithmic knowledge here, but still I should ask, well, how long is this program going to run, right? So here I have a loop of size n is at most 365 really. So this loop is going to take at most 365 steps. Not that bad. Here I have a loop that takes 365 steps for sure. And then I'm looking backwards from that point to the beginning. And then I have some other loop that may loop backwards, but not all the time. But anyway, how bad is it? This is the classic quadratic n square loop. So why do I say that? Because on the the outer loop, it's n steps. And then the inner loop, it's basically I steps, or D in this case, but the loop variable, because the first step, if it's day one, you loop backward one step or 0 step. The second day, you loop backwards one. And then if day I, you loop backwards I steps or I minus 1 steps. And basically you have this classic 1 plus 2 plus 3 plus n minus 1 or n iterations. And this basically is a big O of n squared loop, which for n, it's, for n being 365, who cares? We don't even care if it's n cubed. Does that make sense?
Yeah, it does.
Now I'm going to tell you how to do it in linear time, big O of n, which is going to be a bit harder to understand. But I want to show you the easy way first, and then I'm going to show you the faster way of doing it, even though this problem doesn't require it. But if you have a problem where you have, I don't know, 10,000 steps, 10,000 days you have to cover, then n squared might not be good enough. Okay, so how are we going to basically get rid of this loop? We don't want this loop, and we don't want this loop. Okay, how are we going to do this? All right. So what I'm going to do, I'm using long variable names I normally wouldn't have. It's that as I scan, I'm going to keep track of how many. Okay, let me get rid of all of this. I'm going to keep track of how many 30 things I have seen. Okay, so if 30 at D, then num 30 plus plus. Okay, so this will keep my variable being the number of 30 things I have seen so far, right? Now, why do I care? I'm also going to have dirtiness initialize to 0. I'm going to compute dirtiness as I go. So let me try to explain what's going on. Now maybe I need, okay, so let's say I have something like this. Okay, why is it? Okay, probably because this is not legal C++. So let's try to indent my code somehow. Let me just put in comment. Okay, so I have day 1, 2, 3, and so on. These are the 30 bits. So the number of 30 so far, of course, will be 1, 1, 2, 3. Whenever I see an F, I keep the 1 I had before. Whenever I see a T, it increases by 1. Oops. So the number of, as I step through this array, the number of 30 things I've seen so far are these numbers. Okay. Now, okay, this thing keeps on trying to indent my things that are not supposed to be indented. Okay, so now, what about dirtiness? Okay, how does it change? First day, of course, is 0. Now, what's going to happen now is when I step to another day, then every 30 page I have seen so far will get 1 more. So in this case, there's only 1 dirty page. So it's now 1. Whatever I had before, I add 1. And then whatever I have before, so I don't count this second one yet. even though num30 is 2, I only care about the num30 before. So I add 1, so it will be 2. And here, the next one, I now have 2. The previous one has 2. So basically, when I increase it by 1 day, the dirtiness of each of these 2 dirty ones will now get increased by 1. So it's now 4. What about the dirtiness here? Now I have 3 dirty pages before me, 30 days before me. So every one of them will now increase by, well, every time I moved 1 to the right, each of the 30 days will have this dirtiness increased by 1. So if I have 3 things, now I have to add 7. And then if I keep going in this way, it'll be 10. It will be, let me just make it a little bit wider. And then this would be 14, and then 19, 20, 4. Okay, at this point, it's bigger than I go to 20. I got to wipe everything. So when I wipe everything, what that means is that I need to reset everything. I will need to reset this back to 0, and then this back to 0, and keep going. Does that make sense? Is it all clear what I'm doing?
Yeah, it does make sense.
Right. So I guess the main point is whatever dirtiness you had from the step before, if you have 5, let's say whatever, 5 things that are dirty to your left, then when you move 1 step to the right, then each of those 5 things will have its dirtiness increased by 1. So that means that you got to add 5 to whatever you had before. Okay, this is a bit of a maybe a little bit of a bigger concept. I'm trying, instead of trying to compute the dirtiness from scratch every time by scanning backwards all the way through, I'm actually trying to figure out from one step to the next, how does dirtiness change, and see if I can come up with a simple way to update my dirtiness. Does that make sense?
Would you do like the previous lookup as you did before and just see like if it is going to pass the next time, you go back the day and clean it as well?
Yeah. Okay. So let me start writing this code. So dirtiness, it's simply the number of dirty up to this point. Okay, because I'm looking one back. I haven't updated the number of dirty yet, but I'm looking at the. So if I'm here, I'm looking at the previous value of num dirty, and I'm saying whatever your dirtiness was, I increment it by that much. So that's my new dirtiness. Then I'm going to say if dirtiness it's greater than or equal to 20, now I have to clean up the day before. And that means answer plus plus. But now, instead of actually looping backwards and clear everything, because it's going to be expensive, I'm just going to update a couple of things. It's exactly the same as these 2 lines here. I'm just resetting everything as if I start from scratch. So when I set num dirty to 0, I'm basically saying, I don't care about what happened before. There's just nothing. Okay, I'm just pretending that there are no dirty pages before. And then dirtiness, of course, I reset to 0 because I just clean up. So I don't actually explicitly go back and change these true or false back to false, because that's expensive. I just update these 2 variables. That's all that matters. And then I'm going to update today, right? So now that I clean up, then I'm going to update whether the number of 30 is 1 and so on if today is 30. And then at the end, after I've done all of this, if dirtiness is greater than 0, then I got to clean up one last time. Okay, this one, it's significantly more, I guess, complicated compared to what I did before. What I did before is maybe a little bit easier to understand. But here, I am trying to make it more optimal in the sense that the only loop I have is through the number of days. So it used to be n squared, and now this is just linear time. This inside here, it doesn't matter how many days I have, it's the same amount of code that I run. And the whole point is, instead of going through and computing dirtiness from scratch every single time, I ask myself, can I go from one day to the next and find a simple way to update dirtiness in whatever information I need? And this is very useful technique in computer science, right? You're computing something, so do you compute it from scratch, or do you try to incrementally compute things? And incrementally computing things a lot of times is the way to go. Okay, so now I told you all of this, but does it actually work? So let's see. Notice that I still have not compiled anything. Uh-oh. Okay, so I screwed up somewhere. All right, so much for my perfect record. So now, at this point, let's get rid of this stuff here. So at this point, what are we gonna do? Right, so I'm doing a live session so you can see, what can we do when things go wrong, right? So let's read the code and make sure that we haven't done anything bad here. So d equals to 1, and then dirtiness, it's plus equals to num30. Okay, maybe I'm actually gonna run the sample test cases just to make sure that it passes the sample, in case I notice anything. Okay, so the sample cases are clean ups 1.in 5 145 65 346, and then the other file is 3 310 330. Oops. And then of course I need to go to the directory, and I actually have a script that will compile and run every test case, 4 and 3, 4 and 3. Okay, so at least for the sample, it works. So now the question is, what did I do wrong? Okay. So I compute the dirtiness. Oh, of course it's wrong. Okay, I already see it right away. Did I see it right away? Oh, maybe not. No, I don't see it right away. Okay, so number 30, that's my previous number 30. Okay, and then if it's greater than 20, then I need to clean up the day before. So I remember that I need one more clean up. And then at this point, the num30 is 0. And then dirtiness is 0. So let's see what happens if I have something like this. So this is kind of the debugging stage. I have to start thinking, okay, what can go wrong? So imagine that at some point, I don't know. Let's say at some point that at this point, it's exactly 20. Suppose this is true. Then that means that I have to clean up the day before. So clean up the day before. Okay, fine. And now everything, once I clean up the day before, everything from this point is supposedly false. So then my num30 should be back to 1, which is what I do. And then dirtiness it's back to 0. And then the next day, dirtiness is 1 and so on. So that seems to be in order. And what if it's not less, if it's less than 20? So if it's less than 20, then so num is 0, so dirtiness is still 0, but now num is 1. And then what? And then the dirtiness should be 1 at this point. And then here's 2, and then the dirtiness should be 3 at this point. And then it's still 2. And then the dirtiness should be 5 at this point, and now this is 3. And dirtiness should now be 8, and this is still 3. Okay, I'm not seeing what's going on. I'm not seeing what's wrong yet. Is there anybody that wants to tell me what's wrong?
I'm not sure if this is right, but I was thinking like instead of checking the current day, you check the next day's dirtiness.
Okay, let me think about what you just said. You, instead of checking the next day, okay, so, but I am checking a day and then I'm cleaning up the day before. So if,
right.
If I am at 20 or 25 or whatever it is, then I need to clean the day before. So if everything from this point on is now white to false, then all of these should be now 0. And then all of these now should be 0. And then this will now be, in this case, because it's true, it now be 1. And dirtiness should be 0. And then the next day, dirtiness true. This is still 1 and dirtiness is 1. Okay, so much for this idea. I know that this is the right thing to do, but what did I do wrong? That's the question. I don't know right now. It's a little bit staring at this. What should I do? What would you do if you're in this situation other than calling for help? Of course, we already have a correct solution, so we can always go back to that.
Let's say if I don't have a correct solution and I'm stuck, I might just move on.
Well, so at this point, I mean, there are a number of things you can do. You can try some. Input and see, what happens. So, for example, maybe we say, okay, what if I just have 1 and there's exactly that's day 365. Okay, you can't, maybe this is too small to see. Let me just, so if I have exactly 130 day and it's 365, am I going to catch it? Why do I do this? Because these are the boundary cases. A lot of times when something goes wrong, it's because something at the beginning or something at the end, it's screwed up. So I'm going to try a boundary case. There's something in chat. Oh, no, nothing important. Okay, so I'm just going to run it and see what happens. You see, immediately I found a problem. Why would I get 0? Right, it should be 1. And now I understand why. Because on the very, very last day, if there's a dirty page, I set the dirtiness to 0. And then I don't, when I update the next one, dirtiness, I don't increment it by 1. So what I should have checked is not dirtiness, it's num dirty, greater than 0. That's what I should have checked. And now, okay, so normally I really dislike people Okay, so let me kind of backtrack. When people have code that is wrong, right? Like I did, I have some problems. The first thing that I refuse to do is try to guess, is this part, is it that part, and then just start changing the code, right? I didn't change the code until I know what's happening, until I was sure the change that I make will fix it. Okay, so this is one of the things that I see when I see people in the lab, when whatever class they are in, drives me nuts, is something doesn't work. So let's, adding a 1 there, minus a 1 there, and see if it works. Okay, that's a very bad idea. Do not change anything unless you know why you're changing it and what problem it fixes. I found a clear problem and I know exactly what the reason is and I fix it. I don't say, oh, maybe I need to add 1 somewhere or whatever it is, right? I don't touch the code at all until I know what the problem is. The other thing is, when I try to figure out, what kind of problems there might be, why was I so successful? I tried one test case and immediately I found a bug. It's because I know that often when something goes wrong, it's not because I have something wrong in the middle, especially if I manage to pass 3 cases. It's usually something at the very beginning or something at the very end. I go 1 out of bounds or 1 too little or whatever it is. And it's quite common that you check the boundaries first. That may reveal something. So in this case, that reveals right away what my problem was. And so I submit. And let's see. Let's see if I can do this now. So this is a little bit strange. I'm doing a live coding session in front of you. And but now you also see my thought process about how I do things, and maybe that helps you a bit. So one of the things I said, right? I do not touch my code when I have a bug until I know what I want to change. And I keep telling people, right? If you are watching CSI or whatever, and there's a murder scene, you don't see the officer go in and move something here and move something there. Maybe you move something here, maybe something will change, whatever. The first thing they did was to, put yellow tape around, take a picture of everything, don't touch anything, because it's a crime scene. And as soon as you touch something, you're no longer looking at the same thing, right? So same thing with code. It doesn't work, so that's a crime scene. You start messing around, you start adding a +1 here, -1 there, you're not even debugging the same program anymore. And who knows what else you might have affected. So resist the temptation to touch anything. You can scroll up and down to read, but don't change the code until you know what you're changing. Okay, because it gets really out of hand very quickly. You forget what you're changing and you don't know what you're doing anymore. Okay, so that's kind of a, I don't know, philosophical thing. All right, that took a little bit longer than I expected, but maybe it's also educational when you see that I sometimes don't get things right the first time either. All right. Who else is this? Okay, so let's see here, 16. So the next easiest problem are either jumbo string or intergalactic bidding. I actually don't think jumbo string is that easy, especially you see, even though there are 14 teams, 14 people getting it, 19% of the submissions are wrong, or right. A lot of them are wrong. I'm actually going to talk about house lawn first, and then intergalactic bidding, and then if I still have time, maybe I'll talk about jumbo string. Okay, so house lawn. Here it is. Okay, you have bought a new house. It has a huge, beautiful lawn, a lawn that needs cutting several times every week the whole summer. After pushing the lawnmower around the lawn, you decided that there must be a better way, blah, blah, blah. And then you saw the ads for the new robotic lawnmowers, but which one should you buy? They all have different cutting speeds, cutting times, and recharge times, not to mention different prices. According to the advertisement, a robotic lawnmower will spend all its time either cutting the lawn or recharging its battery. Starting from a full battery, it will cut the lawn at a given rate of C square meters per minute for a cutting time of T minutes, after which it has run out of battery. Once out of battery, it will immediately start recharging. And after recharging for R minutes, the battery is full again and it will immediately start cutting again. You decide that in order for your lawn to look sufficiently prim and proper, the lawnmower that you buy must be powerful enough to cut your whole lawn at least once a week on average. Okay, what does that mean? Formally, if we start the mower fully charged at the beginning of the week and run it for exactly T weeks, it needs to cut the whole lawn at least T times for all positive integers T. Okay, so if you run it for long enough, I guess, it should run it once a week on average. That's what it means, at least. Apart from this, you have no specific requirements. So among the ones that satisfy this requirement, you will simply go for the cheapest. For the purpose of cutting your lawn, you may take the simplifying assumption that a week, it's always exactly 10,080 minutes long. Just out of curiosity, what is 1 week? I mean, 1 week is how many days? 7 days, 24 hours, 60 minutes, yeah? 10080. So why is it, what is a simplifying assumption? What assumption am I making to say that a week is this many minutes long? Isn't this always true? I don't know. Is there some strange European time thing that I don't know about? I thought there's 1 week is always this many minutes long. Anyway, so I guess they're just telling you can assume that. Okay, whatever. The first line of input contains two integers, L and M. L being 1 to 1 million and M being 1 to 100. L is the size of your lawn in square meters, and M is the number of lawnmowers to consider. So that not that many, only 100 of them. Follow M lines. Each line contains a string of N, followed by 4 integers P, C, T, and R, separated by commas describing a lawnmower as follows. N is the name of the lawnmower, at most 60 printable characters, that it doesn't have the comma, and it does not start or end with a space, but internally can be a space, grass layer, for example. Then the next number is 10,000, P, which is the price of the lawnmower. Then C is the cutting rate in square meters per minute. T is the cutting time in minutes, and R is the recharge time in minutes. I'll put the name of the cheapest lawnmower capable of cutting your whole yard at least once. If several lawnmowers share the same price, I'll put all the names in the same order they were given in the input. If there's no such mower, I'll put no such mower. Okay, so the input looks like a little bit of a mess to separate. There's the things are separated by commas, but then internally there can be spaces, so you have to be a bit careful about that. And then the characters can be anything from ASCII 30 to 126. I don't know what that is. Perhaps I don't really care. Okay, so I'm gonna have to read some things. I'm gonna have to read in these strings to parse around it and then do something about it. So let's start. Houselawn.cc. Now I get rid of everything. Okay, so I'm gonna have to have some way of storing the lawnmowers, and do I want to do C++ things, or do I not want to do C++ things? So, okay, I'm gonna have to do a hybrid. I'm gonna have an object, a class, but I don't use class because a struct in C++ is basically a class, except that everything is public. So you probably don't want to do this ever in any of your other courses. Okay, so what do I need to know? I need to have a name. Okay, so I need to have a name. I need to have the price, the cutting rate, and the time for cutting time and the recharge time. All of these is integers. Let me just check. 4 integers, P, C, T, and R. Okay, all of these are integers. Okay, so what do I need to do? I need to know if the first line of input contains L and M. All of these are integers, the number of lawnmowers and the size of my lawn. So I need the size of my lawn. I know that it's it's little l, but I don't like little l because it's hard to see whether it's an L or 1 or whatever. So I just use capital L and then M. So I read that in. And then for each, I need to do a lawnmower read. So how do I do a lawnmower read? I need to have, let's say, mower. I can actually just have an array of up to 100 mowers, right? I think it's up to 100. Yeah, so I can just have a mower, what do I want to call it? Mower 100, like this. And I'm actually going to also have an array number of mowers that I have. I'll explain why later. Okay, so I'm going to have a mower, call it, what do I want to call it? Okay, you have use M, I've used mower, temp. And then I'm going to read it. So I'm going to read it like this with this function. So I'm just going to do a read function here that will read something. So what do I do? First, I have to have a string called line, let's call it. And I'm going to read the whole line. And then I'm going to have to separate things out. Okay. And I know exactly that there are 4 commas. The first comma, it's where the name ends. So I first get the name. So what do I do? IT equals to s dot line dot find comma. That will return actually the index. So I guess I don't use IT as an index. And then if I say line dot substring from 0 to index, that will be everything from the beginning to that point. That would be the name. Then I need to get the rest of this. So what am I going to do? I'm going to say line is equals to line dot substring starting at index +1. So that basically start from the position just after the comma and then to the end rest of the string. Then I'm going to do some STL magics here. This says take all the commas in my line and replace it with spaces. Okay, because I know that everything from this point on is just numbers. I don't have to worry about strings that have spaces. And then I'm going to create something called string stream. And then I'm just going to say ISSP CTR. So this string stream turns the string into an input as if somebody's typing the contents of the string into your program and keyboard, and then I just read it into it's just integer. So I don't have to convert from a string to an integer and all that stuff. Now, this is not going to work the way that I do it. I will miss the first one because when I do C in L, L, and M, it's going to read this part and then leave the input cursor hanging at the end of the line. So the first time I call get line, it will actually just read a blank line. And then the second time I call get line, it will read this one. And this is a common thing you have to worry about whenever you mix sort of this type of input with arrows and then followed by get line. You always have to worry about, are you going to be hanging at the end of a line? So this will basically ignore that end line right after. Okay, so here we are. I read it. Now what do I do? Now I'm going to have to ask, is this mower going to cut it? So this, pun intended. What are we going to do? So it says that the mower has a cutting rate C, and this says that it cuts this many square meters per minute. Okay, so every minute that it's cutting, it's going to cut this much. But how many minutes is it going to cut? Right? You have T minutes that you're cutting, but then R minutes you're going to be recharging. And then you're going to go back and forth, T, R, T, cut, charge, cut, charge. So basically a cycle consists of cutting and charging. So if you have 5 minutes of cutting and 2 minutes of charging, then each cycle is 7 minutes, right? And of that, this many minutes is used to cut. So the fraction of time that you're cutting is this much. Temp T, the amount of time you cut, divided by the length of the cycle. That's the amount of time you're cutting. Okay. Now this doesn't work because all these are integers. I cannot do integer divide and hope for a good result. This is always going to be 0 if I do integer divide. So I have to convert one of them to double. So this is a proportion of time that I'm cutting. I know that the number of minutes per week, it's this much. So if I multiply 10,080 times T divided by this fraction, basically this is the average number of minutes that I'm going to cut. Then multiply by my cutting rate, and that better be at least L. Now I don't know if we got all of that. So this is a cutting rate, how much you cut per minute. This is how many minutes there are per week. So if you just cut all the time, if you don't have to charge, the C times 10,080, it's how much you manage to cut each week. But you don't cut each week, every minute. The proportion you cut, it's basically each cycle, T plus R, that's the length of the cycle. Out of that, you cut T of it. And this is what they mean by average, right? On average, this is how many minutes you cut, a proportion of minutes that you cut. And if all of that is at least the size of your lawn, then this lawnmower can be used. Otherwise, you cannot use it. So if you can use it, then I'm going to store it like this. So this basically stored and also increment the size of the number of mowers that I'm storing. So N is actually the number of mowers that qualifies. Okay, so now if after all this is N is equal to 0, then I just say no, what would I say? No such mower, no such mower. And that's the end of that. Otherwise, out of all of those, I need to pick the one that is smallest, right? So I need to figure out what is the smallest. So what do? Well, I'm basically going to say, a min price, it's equals to the first one, mower 0.p, and then I just loop through. You can ask, why do I start at 0 instead of 1? Because I already have 0. I guess I'm just saying I didn't really care. I don't have to start it. I can start at 1, but I'm just, I guess, habit. It's the minimum of what I have already, and then the price of the iced mower. So this updates the minimum. This computes the minimum. And now I got to print the lawnmower name for everything that matches the minimum. So I'm going to go through this loop again. And you might say, why am I going this loop so many times? Right? Why don't I just update this and then keep track of which ones are the minimum? Well, it's actually a little bit tricky, because if you see that the minimum is the same, then now you have to remember 2 or 3 or 4 lawnmowers of that. But then every time you actually get a new minimum, then you have to clear that list. It can be done, but it's a lot harder than just going through the list twice. And the list is so small anyway, doesn't matter. Okay, so now that I know what the minimum is, I'm just going to say if the ith price is the same as the minimum, now I'm going to print it. So mower I.name. Okay, that's my code. So this one is a little bit more involved, mostly because of this reading thing. The reading is a little bit more messy. And normally I don't use these, I don't know what you call good programming software engineering practices, classes and so on. But for more complicated things, sometimes I will write things like this to organize my data better, just so that I can keep my head clear. Does that make sense?
A little bit long this question, but makes sense overall. Good practice.
Yeah. So one thing that I want to say is I could have just read it into this array of mowers and then try to figure out which one satisfy the criteria and so on. But I just decided it's easier not to stuff things into here unless it's satisfy the criteria. Okay. Questions, comments? Okay. So now, I guess, once again, I'm not going to compile and run. I'm going to use the judge. In the real contest, you probably should make sure that you at least compile it on your machine and make sure it works. To fix my browser so it doesn't always start in my home directory. It should go to my previously used directory. House lawn, it's here. Okay, let's see if it even compiles. Oh, I'm back on the winning streak. Winning streak of 1. All right, so that's how I do this. So, there are lots of things, little things that maybe you didn't notice while I was doing it. So for example, I know that I'm trying to read things one line at a time. And I know that beforehand I was reading it like this. So immediately I need to remember that when I switch from reading with arrows to reading with get line, I have to worry about this potential problem of a new line hanging at the end. So this is always important. So this is something that I always think about when I switch mode of what they call formatted input to line-oriented input. Here, when I was writing this formula, of course, I have to think about what this formula means. But at the same time, another thing, I started dividing, and then immediately my mind goes, integer division, integer division. What do I do? Do I keep the integer division? Do I not want the integer division? So you have to ask yourself, and because I'm doing fractions, and especially here, the numerator is always less than the denominator. So if you use integer division, this is always going to be 0, right? So those are kind of warning signs. When I write code like this, my head already automatically rings alarm bells and then alerts me to a potential problem. Right. So this is maybe if you're as old as I am and get burned enough times when you're young, these alarm bells will start to ring. But I guess it's just practice. Okay, any questions? Okay, which problem did I say I was going to do next? Let's see. There's intergalactic bidding and jumbo string. Okay, let's see, which one do I want to talk about? Who is here still? Okay, there's one more here. There's Rocky. Okay, I'm going to talk about intergalactic. Actually, intergalactic bidding, maybe I'll skip. The reason for me skipping It's because I talked about it last term in person. This is a problem that I actually talked about. So for those of you that were there last term, you might have remembered it, and maybe I'm not going to say anything. I'll just skip this one. You can look at it if you want. You can ask me later. Okay, so which one am I going to do next? I said jumbo string. Okay, now we're getting to things that are a little bit harder. Okay, you see, even though 14 teams solved it out of whatever number, right? So that seems to be big, but a lot of people got it wrong. So this maybe it's not that trivial. Okay, so let's see what this problem is. We call that a subsequence of a string is any string obtained by removing some subset of characters from the string. For instance, if you start with string, then string itself is a subsequence of itself. Sing, it's a subsequence because you got it by deleting T and R. I, it's a subsequence because you got rid of everything but I. S and G is a subsequence because you got rid of everything except the 2 on the outside. Okay, so anyway, you can get many subsequences because you can delete any number of characters. The only thing that matters is once you delete something, so when you delete, let's say, the middle 4 characters, S and G is left, and S and G must be in the same order as the original input. You cannot reorder it. So you can't say GS. GS is not a subsequence. Okay, if the same subsequence can be obtained in exactly T different ways by removing different subsets of characters, we say that the subsequence occurs T times. So if you have, let's say, multiple occurrence of ST, then maybe that can be a subsequence twice. Okay, Jingfei wants to create a non-empty bit string that has the following properties: that the subsequence occurs exactly A times, subsequence of 0, 1 occurs B times, 1, 0 occurs C times, 1, 1 occurs D times. However, Jingfei does not know how to create such a string or whether it is even possible. Can you help her? Okay, the input consists of a single line with 4 integers A, B, C, D. Each of these numbers is between 0 and 1 billion. 1 billion, okay? Output a bit string that satisfies the given requirements. If there are several solutions, output any of them. If there are no solutions, output impossible. Okay, so here, 3, 4, 2, 1, what does it mean? It's you want to produce a string that has 3 subsequences of 0, 0, 4 subsequences of 0, 1, 2, 1, 0, and 1, 1, 1. Okay, so let's see. This is the answer. It says that that's 3, 0, 0. Which 3, 0, 0? The first one and the second one. That's 1. The first one and the third one. That's 2. And the last 2. Those are the 3 possible subsequence of 0, 0. Okay, before I go on, does that actually make sense? Because if it doesn't make sense, there's no point of me continuing further. Okay, so I have 3 zeros. So any pairs of 2 zeros is a subsequence of 0, 0. First one with the second one, first one with the last one, and then the last 2. Okay, now it says the subsequence 0, 1 occurs 4 times. How can you have 4 times? Well, 0, 1, this one. That's 1. This 0 with this 1, that's another one. That's 2. Then this 0 with this one, that's 3. And then finally the last 2 digits, 0 and 1. Okay. This 1 does not form, this 1 and this 0s don't form a subsequence of 0, 1 because they're in the wrong order. And then it says that there are 2, 1, 0. So which 2, 1, 0? This one. And then also 1 with the other 0. And then finally, 1, 1 occurs 1 time. Well, 1, 1 occurs, there's only 1 copy of 1, 1. So 3, 4, 2, 1, the answer is 0, 1, 0, 0, 1. Okay. Okay, so maybe you don't know how to construct this answer, but do you actually understand why this is the right answer? that's more important for them. Okay, no questions. All right, then 5005. So it says that 5 times occurs 0, 0 occurs 5 times, no 1 zeros, no 0 1, and 5 1 1s, and then it says it's impossible. What are we gonna do? What are we gonna do? Okay, this time I'm not actually gonna write code now. I want to just kind of maybe just explain how to think about this problem. Okay, so you have A 0 0, B 0 1, C 1 0, and D 1 1. Okay, and then you have to construct some string. So A, B, C, and D also, they also tell you that A, B, C, and D are between 0 and up to 1 billion, which is really big. And you want to produce some strings of 0, 1, whatever, that so that the number 1 0 0 0 subsequence is exactly A, and so on. Okay, how many? We might ask. Okay, we know that it's just 0 and 1. How many characters? How long is this string going to be? Do we even know how long this string is going to be? Does anybody know? Okay, maybe we don't know. I mean, these numbers are really long, right? These numbers can be up to 1 billion. So do we have to make a string that's 1 billion characters long? That's a lot of characters to output. Thankfully, no. Okay, so how are we going to think about this, right? Let's think about the simplest kind of strings and see what we understand. Let's say the simplest kind of string is just zeros, no ones. Okay, so how many zeros did I put? 10 zeros. So I have 10 zeros. If I have this string, what are the values of A, B, C, and D? How many 1 1s do I have? Nothing. How many 1 zeros do I have? Nothing. How many zeros 1 do I have? Nothing. Those are the easy things. Okay, because I have no 1s, there cannot be any subsequence that involves 1. But how many subsequence of A sub 0 0 do I have? Can anybody tell me? Okay, let's make things even simpler. I have this one string with 2 zeros. How many 0 0 subsequence do I have? 1. There's only one way I can form this subsequence. Okay. Oh, there's some chat. Do I want 10s? Well, you have to speak up because I have to monitor my chat here. No, not 2 factorial, just 1. Okay, because it's just there's only one possible pair of 0 zeros. There's only one way I can delete characters to get 0 0, and that the only one way is to not delete anything. Okay, now let's look at this. Okay, how many ways can I delete zeros to get 0 0? Well, there's 3 of them because I can delete each of these 3 zeros to get 0 0. Okay, what about 4? Now things are a little bit trickier because I can delete any 2 zeros to get 0 0. So how many ways can I delete any 2 zeros? It's the binomial coefficient 4 choose 2. I can, from the 4 zeros, I can choose to delete any 2 of them, and turns out to be 6. I can decide, what if I have 5 zeros? Well, from 5 zeros, I can choose to delete any 3 of them, and that's 10 ways. I can also say, instead of saying I can delete any 3 of them, I can also say choose to keep any 2 of them. So if you've been following so far, going back here, if I have 10 of them, how many subsequence of 2 zeros are there? It's this much. I have this many ways to decide which 2 to keep. And if you work it out, this is 10 times 9 divided by 2, which is 45. And in general, A, it's equals to n times n minus 1 over 2 if there are n zeros. Okay, so what does that mean? If I know that, and it doesn't matter, even if this string has some other things like 1 somewhere, okay? If I'm just looking for the number of subsequences of zeros, 2 zeros, I can actually completely ignore the ones. It doesn't affect anything. So if I want to know what A should be, if I know how many zeros there are, I can just use this formula. So let's cut n0, which is the number of zeros. And by the same argument, if I know what is the number of ones, then the number of ways I can have 1 ones as a subsequence is exactly this. Does that make sense? Okay, so now if that makes sense, so assuming that it makes sense, that gives you a big hint. Why does it give you a big hint? Because if they tell you that A is 5 or whatever it is, let's see what they say. It's 3. Let's say A is 3. Well, you can ask for what value of n will n times n minus 1 over 2 equals to 3. If you don't like to do it with any hard math, I guess you can just try. Plug in n equals to 0. Well, n equal to 0 is just 0. N equals to 1 is 0. N equals 2, 3, and so on. And you'll discover that n0 is equals to 3. Because 3 choose 2 is exactly 3. And then D, in this case, is 1 in this problem. And then you discover that n1 equals 2. 2 times 1 divided by 2, that's exactly what gives you D equals to 1. So if you can solve, if you can find, n0 and n1 from 3 and 1, then you know right away, just by looking at these two numbers, that you know that there are 3 zeros and 2 ones in your string. You don't know how they arrange, but you know that these are the number of zeros and ones. And so, of course, that also means that you have exactly 5 characters. Does that make sense? If, for example, A is 5, then you discover that actually there is nothing so that n choose 2 is 5. You cannot find an n value that will work. In that case, you just say impossible. That's it. Okay. Now, yeah.
Where would the D equal to 1?
So what's that?
I was trying to figure out why the D was equal to 1.
Because this is the input.
Oh, okay, I got you.
Yeah.
I thought it ended in 2, sorry.
Yeah, sorry, I was looking at the sample input.
No, that makes sense.
Okay, so now, you can do a linear search, try n equals to 1, 2, or 0, 1, 2, 3, until it works. And if it gets too big, then you know that that's good enough. So you might say, well, yeah, how bad is it? I mean, if I do linear search, one at a time, is it going to take too long? Because these numbers are up to 1 billion. Well, it turns out to be not so bad. Why? Because these numbers here, this is basically Cn2, it's equals to n times n minus 1 over 2. And if you want, you can rewrite it as 1/2 times n squared, whoops, what did I do? N squared minus n. So this is a quadratic, right? It grows quadratically. So basically, it will go up to about the square root of 10 to the 9. And square root of 10 to the 9 is roughly 10 to the 4, 10 to the 5. And so basically in 100,000 steps, you'll find it. Okay, or it'll be too big. But of course, if you don't like it, if you don't like that, that's okay. Whatever number you're given, you can turn this into a quadratic equation, right? So this is 0 is equal to 1/2 times n square minus 1/2 times n minus a is equal to 0. And so you have a quadratic equations where the first coefficient is 1/2, second coefficient is negative 1/2, third coefficient is negative a. You use your favorite quadratic formula to compute the roots, hope that it's an integer, and so on and so forth. Okay, so you can do that. But for this problem, it's good enough just to search. Okay, so far, what have we managed to do? We have managed to figure out how many zeros and how many ones there are. But we haven't used B and C. And because of that, we don't know how the zeros and ones are arranged, right? We just know that there's 3 zeros and 2 ones. So it could be 0011 or maybe, I don't know, 1100 or some other arrangement, right? Which one of these is right? Okay, so now we have to think a little bit more. Okay, so now what we're going to do is we're going to look at the number of 0 ones and number of 1 zeros. So it says, for the first example, the number of 0 1 is 4, and the number of 1 0 is 2. Okay, so now the first question is, am I going to put zeros or am I going to put ones? All right. If I put a 0, so now I know that the number of zeros I have to put is 3, and the number of 1 I have to put is 2. And I'm going to start writing from left to right. So I'm going to put the first one. What am I going to put? Well, there are only 2 things I can put. I can either put a 0, I can put a 1. Right? If I put a 0, what's going to happen is I still have 2 more 1s to come, right? I still have 2 more zeros and 2 more 1s to come. I don't know in what order, but I know that these are what's to come. If I put a 1, I know that I have 1 more 1 to come and 3 more zeros, like this. Now let's look at the second situation. If I put a 1 here and I know that there's 3 more zeros to come, then immediately, no matter how these 3 zeros are arranged, I know that I'm going to have 3 1 zeros showing up. Right? Even if it's like this. I'm going to have the 1 0 here, 1 0 here, and 1 0 here. I'm going to have at least 3 1 zeros showing up. And I look at this and I say, oh, I can only have 2. So if I put a 1 here, that's going to ruin things because I will create 3 1 zeros. Does that make sense? So this one is bad. You cannot put a 1 in the first position. It forces you to put a 0. So first position has to be 0. We don't know what's next yet, but we know that now at this point there are 2 zeros and 2 1s left. But now that we put a 0, and now that we know there are 2 1s, we know also that we just created 2 subsequences of 0 1. So now we have to look at this and say, okay, am I allowed to make 2 subsequences of 0 1? Yes, because I'm allowed to make 4. So, okay. So now I'm going to subtract 2 from here. And from this point on, I still have to make 2 more 0 1s. So at this point, I managed to fill out the first bit to be 0. And I know that with the remaining 4 bits, I need to fill out 2 more zeros, 2 more 1s, and then I have to create 2 0 1s and 2 1 zeros. Now I do the same thing again. I ask, can I put a 1 0 here, or can I put a 1 here? Right, so I do the same thing. If I put a 0, now the rest of it is 1 0 and 2 1s. So I'm going to create 2 more 0 1s, which according to this is okay. Or in here, if I put a 1, then I'm going to create 2 more zeros and it's 1. So it's also okay. So what do I do? Okay, what do I do? Well, I have to try. So let's say I try this one. So now I have, if I try this one, I now have 1 more 0 to put and 2 1s. And then I already created, I can no longer have more 0 1s. Okay, because I just used up another 2s. And then the only way I can do this is just put 1 1 0, because I cannot create any more 0 1, so I cannot put 1s. I cannot put other zeros before the 1. So here's one way to do it. So let's just make sure that it is right. So I have 1 0 1, 2 0 1, the first one, and the, so this, how do I do this? So I have 0 1 like this. That's one of them. That's the second one. That's a third 0 1. And then that's a fourth 0 1. So there are 4 0 1s. And then when it comes to 1 0, that's one of them. And the other one is here. And then the A and D would just work because that's how that's what I computed. So that's one answer. And then the other answer, I started with this. And now, okay, so now what do? I have to backtrack because at this point I started with 4 and 2, I lost 2. And then when I put a 1 here, I still have 2 zeros. So I lost both of these. And now I must make sure that I put 0 0 1. Okay, and it will turn out, I think this is the answer that they gave. Yes. Yeah, that's the answer they gave. So it turns out that both of these, I was able to continue. Both of these are valid solutions. And it does say that if there's several solutions, you can output any of them. So that's basically, I didn't write any code, but that's basically what I'm doing. Okay, so I'm basically going through and ask this, can I put a 0 or can I put a 1? If I can put a 0, that means it's good. If I can put a 1, that means it's good. That when I do it, either way, I only have to choose one. If both of them are good, I can choose either one. And if at any point, I get stuck because both ways are bad, then it's impossible. Okay, so does that make sense? What is this called again? Jumbo string.cc. Okay, no, I don't want, this is not code. Okay, so I'm gonna start writing code. So notice that I didn't really write a lot of any code. I have to figure out what it is that I'm doing before I even write any code, right? If I don't know what I'm writing, it's hopeless to try to solve it. So I have A, B, C, and D up to 1 billion. So a normal integer type is good enough. A normal integer type will hold up to 2 billion. Okay, and now I have to figure out number of zeros and number of ones. So I'm going to write a function, in this case solve, and number of ones, solve D. Okay, so I have to figure out the number of zeros and number of ones. So how do I write this function solve? Int solve int A. Okay, all right, I guess I was using n. And then I say for int I equal to 0, I, well, I don't know what I is, so my answer, actually, this is, I just do an infinite loop. Is it an infinite loop? Let me think. So if answer times answer minus 1 divide by 2. If it's bigger than n, then I can quit. Otherwise, I keep going to look for it. If answer times answer minus 1 divided by 2 is exactly n, then I found the answer. And if I quit this loop and without finding it, I'm just going to return minus 1 to indicate that there's no answer. Okay, at this point, I stop and I say, is this correct? Right, I'm looking for something. I guess I shouldn't use n. This is a, and then I'm looking for n in my formula below. So I should maybe I should use n instead, so I don't get confused between this code and what I wrote before. Okay, I wasn't really confused, but maybe you were, so let me just change it back. Okay, like this. And this code, it's probably going to fail. I don't know for sure, but I'm willing to bet that this will fail. Why is it going to fail even? What am I worried about here? Does anybody know? Assuming that you believe that the algorithm is correct. This A here, it's up to 1 billion. So when I'm computing n, that is big, relatively big, sort of compared to the square root of A, and then when I compute n times n minus 1 and so on, I can actually overflow. This part can actually overflow an integer, a 32-bit integer. And then if it overflows, and then all bets are off. Everything is going to be wrong. So I'm going to, even though I started with integers, 32-bit, the original input, it's all good with integers. I am going to make it a long 64-bit integers. Okay, so that will make sure that I'm not going to overflow. Okay, so now if n0 is less than 0 or n1 is less than 0, so if either one of them is unsolvable, then I'm just going to say, what am I going to say? Impossible. And quit the program. Okay, now what else am I going to do? Then I'm going to start building the string one by one, right? So I know, so if n0 is greater than 0, so if I still have to make zeros, and what else? If I put a 0, that will introduce n1 0 ones. So, and 0 1 is b, so b, it's greater than or equal to n1. So if I still have enough, then I'm going to print a 0. And then I'm saying en0 minus minus. And then n1 b is minus equals to n1. So this is basically I print a 0 if I can afford to do that by introducing more ones, by introducing more 0 ones. So however many ones I still have left to my right, that's the number of 0 1 that I'm going to introduce. Else, if n1 is greater than, so I still have a 1 that I can use. And by adding a 1, I'm going to introduce n0 1 zeros. Then I can, as long as I can still do that, I'm going to print a 1. Actually, I don't want to print. Okay, so this is bad because I'm printing as I go, but I might get stuck later. So I don't want to get stuck later. So I'm actually want to have a string that I'm building, and then s would be appended by this character. S would be appended by this character. If I cannot do that, if none of that works, then I need to say break. Okay, but this only gives me 1 character, so I need to loop over it. So what do I need to loop over? for int. Well, I was going to say go from n0 plus n1. Okay, I was going to write this, but I stopped myself from writing it. So, but I'll write it anyway. Why is this bad? Because my n0 and n1 are changing. Okay, so so if there are 3 zeros and 2 ones, I want to loop 5 times, but this is unsafe because my n0 and n1 keeps changing as I go through the loop. So I might not actually do 5 steps. So what I should do instead maybe is to just say, wow, n0 plus n1 is greater than 0. So I still have something that I need to add because my my n0 and n1s are getting decremented every time I have another character added. And then if I haven't managed to get impossible and exit the program, that means my S must be good. Okay, let me erase all this other things. Okay. I don't know if that makes a lot of sense. This is definitely getting more complicated. And this time, I'm actually going to run the program because it is complicated enough that maybe I'm a little bit less confident that I know exactly everything that I did was completely correct. So I'm at least going to run the 2 sample inputs. What is this called? Jumbo string. Aha, you see, something bad has happened. So what do I do, right? So I can print impossible in many different ways. So what do? Let's see if I can manage to get out of. Let's just print n0. Now I did say, don't touch your code. I'm not changing the code other than adding output statements, okay? I'm not changing the logic of the code. Aha, so I actually never even compute n0 and n1. I just quit right here. Okay, so that's the issue. So why is that? N times n minus 1, it's equals to over 2, it's equals to a. So if a is 3, then 3 times 3 minus 1. Oh, you see, I made a stupid mistake here because I wanted to stop the loop when it's greater. But of course, in a for loop, this is a condition to continue, not to stop. So I inverted my test. So this loop never executes. Okay, so again, you notice that I never change anything until I know what's wrong. Okay. Okay, so 0, 0, 1, 7, 0, that's one of the possible answer. I have this extra debugging output, which I have to get rid of. Okay. But it looks right. It's not the same, but it's okay because this is one of the possible answers. There are multiple answers, so I'm submitting it. Oh, I get to get out of this contest. Contest practice temp jumbo string. Submit. Okay, let's see. Oh well, that's not gonna work. Okay, I don't know what's happening yet, but maybe it's getting close to the time, so I don't know if you want to see me debug here. Anyway, I'll continue. Maybe I'll send something on Discord once I fix it. Maybe it's getting a little bit late. Okay, so I'll have to figure out what the heck is going on. And oh no, I already know what's going on. because you see, I decremented B, but here I completely forgot to decrement C. So for sure it's wrong. This is for sure a bug. I was surprised that it works in the sample input, but I guess sample input is easy. Okay, so I know that there's a bug. I know exactly what the bug is and fix it. So let's see. I really have to figure out a way to have it remember the lost directory so I don't have to do this every single time. Nope. Okay, so something else is wrong. Say for sure I fixed the bug, but maybe I didn't fix all the bugs. So I have to go back and try to figure this out, and I'll send something on Discord later once I figure it out. Okay, anyway, that's kind of the idea. Maybe I screw up somewhere. So how many did I actually do today? I did 3 and stumbled on the last one. All right. So I'll stop here because we're getting to the end. Yeah, I don't know if this is helpful watching me do this stuff like that. But anyway, I'll try to do it in front of you. The problems I chose today, I guess, are not, except for the last one, are not that hard algorithmically, but it is still a good practice to try some of these, what I would call simpler problems. But I did not have to pull any complicated algorithms to solve these problems, but just getting familiar with solving some of these simpler problems and writing concise code that works, that's definitely something that you want to do.